Whenever you see a polynomial that has 4 terms, the chances are good that you will be using factoring by grouping in order to factor it completely. So write down this problem here and make sure to look at your factoring flowchart. You'll notice that it says when you have 4 terms, you're most likely factoring by grouping. We call it factoring by grouping because we do just that. We group the first 2 terms together and we group the last 2 terms together. Looking only at those first 2 terms, your job is to say, do I have any greatest common factors between those first 2 terms? And hopefully you see that it is 9t squared. So I'm just going to treat those first 2 terms as if I'm factoring out a greatest common factor. After I divide the 9t squared by both of the terms, you end up with 3t plus 5. Next we move over to the second 2 terms, the negative 3t minus 5, and do the same thing. We look for a common factor and factor it out. And in that case, there's only one common factor, and that's a negative 1. So when I pull the negative 1 out of that by division, I end up with 3t plus 5 inside of that quotient. Now here's the really important part. If you look at this entire expression right here, you see that you still have another set of common factors. 3t plus 5 is a factor that is common to both of those terms. And so one more time we pull out the greatest common factor and divide both terms by it. If I divide this expression by 3t plus 5, this kind of just goes away, and you're left with the 9t squared. If I pull the 3t plus 5 out of this expression, you're left with minus 1. You have factored by grouping, but you are still not done because you are not factored completely. This factor here, 9t squared minus 1, is the difference of squares pattern, so we can continue to factor this into even smaller terms. My 3t plus 5 is still a factor, so I'll leave it there. But when I factor 9t squared minus 1, you end up with 3t plus 1 times 3t minus 1. Now you are factored completely. We'll do more guided practice with this in a second, but I want to jump into quadratic form quickly. This looks scary. It certainly is not. Let me show you how it's not scary. If I looked at example A and I said this was 16x squared minus 81, you would recognize that this too is the difference of squares pattern, and you would have no problem breaking this up by squaring the first term and squaring the last term to come up with your terms inside of these binomials. Quadratic form means simply that you have powers that are even for your highest degree or leading terms. And so we're going to factor 16x to the 4th minus 81. And the only thing that changes is the look of your first terms in these binomials. So when I square root 16x to the 4th, you end up with 4x squared instead. And then you still have 9 in the first and last position. So really you can see there's nothing really different here. You just need to not be afraid when you see higher powers for your degree. Let's do B. Write that problem down. I'm going to erase these and get them out of my way. But as always, we should start with a greatest common factor if we have one. And this expression has a greatest common factor of 2p squared. When I divide out a 2p squared, I get p to the 6th power plus 5p to the 3rd power plus 6. Again, this is like a standard polynomial or trinomial that you're used to factoring. This trinomial will factor into 2 binomials. The only difference here is you need to use your exponent rules to figure out what your first 2 terms will be here. P to the 6th will be gotten from FOIL if I put p to the 3rd in both of these positions. And then you ask yourself the same question. What two things when multiplied will get me 6, but when we'll add it will give me 5? Those would be plus 3 and plus 2. You may not want to trust yourself, and you're certainly welcome to always FOIL these back together to prove that this is the product of those factors. Let's practice these new types of factoring. Write down these 3 examples. Following your factoring flowchart, you can see that number 5 does not have a greatest common factor. And it has 4 terms, which is an indicator we'll be factoring by grouping. Again, we group the first 2 terms together and the last 2 terms together and deal with them separately. Looking at the first 2 terms, my greatest common factor would be x squared. Divide that out to get x plus 7. Move on to the second pair. You're going to factor out a negative 9 from both of these because that's what they have in common. And then you end up with x plus 7 again. And a little indication you're doing it right is that these 2 factors should match. It's because they match that I can divide them out of both of these terms and rewrite using the reverse of distribution x squared minus 9 inside. Again, if you don't believe me, go ahead and multiply this times that first term and this times that second term, and you will see that you produce the line above it. We are not done though, because I have a difference of squares pattern again. So I will write down x plus 7, that's one factor, and then x plus 3 and x minus 3. And now you have factored it completely. Let's look at example 6. This is an example of quadratic factoring. If that was a g squared in that example, you would have no hesitation in doing this. Just because it's g to the 4th does not stop us. So what we'll realize is this is a difference of perfect squares pattern again. And this will factor into 2 binomials, where you take the square root of 16g to the 4th, and that's 4g squared. Now, take the square root of 625, and you'll see that it is 25, with a plus and minus sign. We're still not factored completely, though, because this second factor here is a the difference of squares. This one we're done with, but this, because it has a minus sign and 2 perfect squares in that position, means we need to go further. So I will write down the first expression, and then factor the 4g squared minus 25 into 2g minus 5 times 2g plus 5. Let's look at number 7. Number 7, following the factoring flowchart, makes us pull out the 4, that is the number that's a common factor, and a t squared. Dividing all those terms by 4t squared, you get t to the 4th power minus 5t squared plus 6. We need to keep going though, because that trinomial will factor into the 2 binomials. T to the 4th will be broken up into t squared and t squared. Again, because if you FOIL these, you're getting your t to the 4th. What 2 factors, when multiplied, give you 6, but when added, give you a negative 5? I do realize that this might be difficult, but the more you practice, the easier it will become. Remember, there's not anything totally new happening here. We're building off of concepts we've already seen. So just have no fear and dig into that homework and you can do it. And remember, you can always ask questions.